Chapter 4 is called Designing Studies, and Section 1 talks about samples and sampling methods and surveys. So in this section, we will discuss identifying the population and the sample in a statistical study. We'll identify the voluntary response samples and convenience samples and explain how these methods can lead to bias. We'll describe how to obtain a random sample using a variety of methods, including slips of paper, technology, or a table of random digits. We'll distinguish a simple random sample from a stratified random sample or a cluster sample and talk about advantages and disadvantages for each. And we will explain how undercoverage, non-response, question wording, and other aspects of a sample survey can lead to bias. First of all, a couple of terms. A population in a statistical study is the entire group of information of individuals we want information out about. A census will collect data from every individual in the population, where a sample is a subset of individuals in the population from which we actually collect the data. Population, the big group we want to find out about. Census, asking everybody. Sample, asking a subset. So we've got the population, the samples inside of that. We collect data from the sample, and we use that data to make an inference about the whole population. Now, if my method is good, then this sample is likely to represent the population. If my method is crummy, then my sample is not likely to represent the population, and therefore this inference would be inappropriate and inaccurate. We often draw conclusions about a whole population on the basis of a sample. So choosing a sample from a large varied population is important, but it's not easy. First of all, we want to describe the population we're interested in and say exactly what we want to measure. A sample survey is a study that uses an organized plan to choose a sample that represents some specific population. So then we need to figure out how we're going to get that sample out of the population. How can we choose a sample that we can trust to represent the population? Well, one method is a convenience sample, and that's simply choosing individuals from the population who are easy to reach. They're nearby, they're close, they're standing right there, they're easily obtained. But that often produces unrepresentative data. The design of a statistical study will show bias if it would consistently underestimate or overestimate the value you want to know. I like to say it like this. Bias is a systematic favoring of a certain outcome. Now, bias doesn't have to mean that you did it intentionally. It may be an unaware bias, but the method, the system, the methodology is what's causing the problem here. Convenience samples are almost guaranteed to show bias. So are voluntary response samples. Voluntary samples or voluntary response samples come when people decide whether to join the sample. There's an open invitation. People just voluntarily join. These people often have very strong opinions and may not represent the larger population. Therefore, we have bias. A sample chosen by chance rules out both favoritism by the sampler and self-selection by the respondents. And again, this favoritism by the sampler may be an unaware favoritism, but something involved in the methodology made it more likely for them to favor certain outcomes. That's what the idea of favoritism comes in, not necessarily because they chose their favorites to be in the group. Random sampling involves using a chance process to determine which members of a population are included in the sample. A simple random sample is called an SRS, and it's chosen in such a way that every group of n individuals, maybe I'm picking 10, so every group of 10 individuals in the population has an equal chance of being selected. Every group, not just every person, but every group of whatever I'm looking for. In practice, people use random numbers generated by a computer or a calculator to choose samples. And if you don't have technology, you can use a table of random digits. We'll talk about that in here because they're easy to draw on so that we can understand exactly what's going on and I can make sure that you understand what's going on. So with technology, I might use a calculator such as a TI-84 and ask it to find a random integer. I label everybody in the group 1 to n, and then I use a random number generator to select people on that. So given everybody a number, and then I pick random numbers. Same idea on table D, which is what this PowerPoint refers to as the table of random digits. So I'm going to give everybody a numerical label with the same number of digits. So if I have 30 people, I'm going to start with either 00 or 01 so that everybody has a 2-digit number. Use as few digits as possible. So if I have 30 people, I don't need to call the first person 00001. Then I use the table to find consecutive digits of that length. If those digits aren't used, I ignore the digits entirely and I go to the next one and I stop when I've chosen however many different labels I need. Your sample will contain the people whose labels match the numbers you got. So, for example, here's 28 hotels that were numbered 01 to 28. Some people choose to start at 00 and they would stop at 27, but it's clearly listed here how they named these hotels. Since they named them with 2-digit numbers, we're going to look at this table in 2 digits at a time. There they are, 2 digits at a time. Same number, 69, 05. Now this space here is only for visual purposes, so this is 16. There it is, 4817. And I needed to find 4 hotels. I don't have a Hotel 69. I do have a Hotel 5. It's Beach Castle. I have Hotel 16. That's the Radisson. I don't have a 48. There's 17, the Ramada. There's 87. Oh, look at this. 17 again. Well, and I've marked out here all the duplicates. These 17s that are repeated are not helpful to me because I've already got the Ramada in my sample, so I go all the way here to number 20, the C Club. There may be occasions where you can allow numbers to be selected repeatedly, but in this case, if I wanted 4 hotels, I need to go until I get 4 hotels. The basic idea of sampling is pretty straightforward. Take an SRS from your population, use your sample to gain information out about the population. Sometimes there's advantages to using a more complex method, and I'll talk about some of those. So one of them is called a stratified random sample. And in a stratified random sample, I first classify the population in smaller groups called stratas. Then I get an SRS from each stratum, combine those SRSs to form a sample. So for example, maybe I divide all the students in a high school by grade. 9th graders, 10th graders, 11th graders, 12th graders. Those are the stratas, and they're similar. Now I take an SRS of, say, 5 students from each grade. So I have 5 random freshmen, 5 random sophomores, 5 random juniors, 5 random seniors. I combine them together to get a random sample of 20 high school students. Now this sample is not a simple random sample, because you'll recall that in a simple random sample, all groups of a certain size have the same chance of being picked. The method I just described is impossible to get 20 seniors. That method can't get 20 seniors. I'll always only have 5 seniors. That's what makes it not a simple random sample. However, within each grade level, I did have a simple random sample. All groups of 5 seniors have the same chance of getting picked, just not all groups of 20 high schoolers having the same chance. So this method is called a stratified random sample. Don't be confused. SRS always means simple random sample. Although a stratified random sample can sometimes give more precise information about a population than an SRS, both sampling methods are hard to use when populations are large and spread out over a huge area. In that situation, we might prefer a method where we can select groups of people close to one another. This is called a cluster sample. To get a cluster sample, start by classifying the population into groups of individuals located near each other, called clusters. Then, choose an SRS of the clusters. All the individuals in the chosen clusters would be included in the sample. So here's a rough idea. This isn't perfect because my classroom sizes aren't the same, but imagine a school where we had, I don't know, 100 teachers teaching during third period. A cluster sample might say pick 5 random teachers and then go and examine or question all the students in those 5 teachers' classrooms. So I have a cluster of students. They're clustered by homeroom teacher, and I pick 5 random teachers and go get all the students or all the individuals in that classroom. The purpose of a sample is to give us information about a larger population. The process of drawing conclusions about a population based on the sample data is called inference. So why do we rely on random sampling? Well, first of all, random sampling helps us avoid bias in selecting the samples. Second reason is the law of probability allows trustworthy inference about the population. So before I look at those bullets, here's what that means. If I've taken a random sample, the law of probability says it's reasonable to think that that random sample represents the spectrum of ideas that would be found in that population. Because I've eliminated the bias, the systematic favoring, the population could be expected to be well represented in the sample. Results from random samples come with margin of errors that set bounds on the size of the likely error. In other words, if I am taking a sample of high school students to estimate the average height of a high school student, and I sample 30 high school students and I get their average height, I don't expect the true average height of the whole population to be exactly what I got, but it's reasonable to think that it's close to what I got within some margin of error. Moreover, larger random samples will give better information than smaller samples. So instead of sampling 30 high school students, if I sampled 100 high school students, I would be more likely to get an average height that's closer to the true average height. So what can go wrong? Well, most sample surveys are affected by errors in addition to sampling variability. Sampling variability is some random differences. If I go sample 30 high school students and measure their height, and you go sample 30 random high school students and measure their height, even though we both got random high school students, we're likely to have different answers, slightly different answers. That's sampling variability. Good sampling technique includes the art of reducing all sources of errors. Sampling variability is not an error, it's just a luck of the draw kind of thing. So here's some ideas. Under coverage. This is a source of error, a type of bias that occurs when some members of the population cannot be chosen in the sample. If I elected to send text messages to randomly selected high school students to ask them their height, some students who don't have cell phones won't be covered. That's under coverage. Non-response occurs when somebody can't be contacted or refuses to participate. So similar example, I text somebody, I ask them how tall they are, and they won't return my text. That's non-response, another source of bias. A systematic pattern of incorrect responses in a sample survey leads to response bias. Perhaps the way that I'm asking the question is confusing or is set up in such a way that students aren't going to be truthful. That could be response bias. The wording of questions can be very influential on answers given to sample surveys. So if the question was confusing or misleading, or I set it up in such a way that it prompted you into answering a certain way, it's got bias. In this section, we talked about identifying the population and sample in a statistical study. We identified voluntary and convenient sample methods and talked about the problems or the bias that could occur there. We talked about how to find random samples using technology or a table of random digits. The idea of slips of paper just means putting everybody's name in a hat, mixing them all up real well, and drawing them out. A very straightforward way of getting a random sample if my sheets of paper were identical. We distinguished a simple random sample from a stratified random sample or a cluster sample and talked about reasons why you might want to do that. And we explained how undercoverage, non-response, question wording, and other aspects of the survey could lead to bias.